Welcome everybody. Today we're going to look at how to create the pin tip and then also a couple different styles of holders for your pin. So let's get started. I've already got the pin tip made, so we're just going to go into it and just take a look at how it was created. So essentially it is um, basically just a profile that we're going to revolve around this axis here. And we've got some dimensions that we've put in place. And we'll talk through those and kind of how we figured this out. If you take your pin tip, it's going to insert into the brass tube. So the diameter of the part that goes into the brass tube is essentially the inner diameter of the brass tube. There is some detail on the pin tip to help it stick in there, but we're not going to worry about that. We're just going to, we just want some basics here of what it looks like. So these are kind of your overall dimensions that we found. So we measured the diameter of that, which should match up with the diameter of the wood. Um, like there's a flat spot on the wood that we created, or you can go into an old sketch and show an old sketch, but I would just maybe do the diameter that we've already used for for the ring and for the end cap here. You can use that same diameter for the diameter of the pin from here to here. And then we just use the offset step on our dial caliper, which is kind of on the back side where we have those two parallel plates. We measure from here to here, and that gives us the 0.165. And then this dimension is a you don't need for right now. We're going to use it when we make our holder, but I didn't actually have this when I first made the pin tip. We just measured the total length from the end of the insertion point down here to where the pin ink cartridge comes out, and that was 0.982. And then we measured just the diameter of this end of the pin tip, and I got 124 thousandths. And then we just measured the diameter of the hole, which was 80 thousandths, so that means the radius would be 40 thousandths on that. And that's it. This dimension, again, we don't need this. This was added later when we are figuring out some of our holder designs. We came back in and added a horizontal line and found what that taper angle is. So when we do an extrude for this pin tip to sit in, we can do an extrude taper, and we can use that angle um, for our taper angle for when we make the holder. And that's what this was for. We needed to know how deep the hole needed to be for the holder so that the pin tip fits down in it. So that's what these numbers are for. They're driven numbers because we don't actually the geometry doesn't require them, and they're fixed based on our other dimensions. So if you change one of these dimensions, it automatically updates this as a result. Yeah, but this is what we have. Again, the end of the pin tip doesn't look like this. It's got a opening, and it's more looks like this, where this comes down, and then there's kind of a shoulder. But we're not modeling that. We're not modeling the internal portion of this to see where the spring sits down in there, or the I guess there's not a spring in this, but anyway, we're not doing that, so I wouldn't include that. But this is really what you need. And then when you finish your sketch, again, we're just using the revolve command. We're going to pick this upper portion, and then we're going to pick our axis right here down the midline, and then do a full revolve. And this is what we end up with. I'm going to activate the tip. It looks like that with the hole through the middle. And then we just, once we did that, we joined it to the brass tube and got it in position, and we are ready to go. What just happened here? I don't know what just happened with all this stuff. Okay. Well, we're just going to put this back together. So That was interesting. Okay, so we'll rejoin this with this, and then we will put the pin cap on the end, just like so. And then we will join this end here to this end, and we'll flip it. Say okay. And there's our pin, fully assembled. So hopefully that helps you get going on the full pin. Let's look at our two different styles of holders. This is a holder that I made that is going to be laser cut. And actually I kind of messed this up. We laser cut it yesterday and realized that the thickness of the wood is 0.12, and I did this extrusion here as 0.20, so when we cut it, the tabs of this were sticking out too long. So we've got to go back into this holder design, and we're going to go back to the original sketch, which is this here, and that original extrusion should be 0.12. But the cool thing is because I modeled these risers off of the base plate, whenever you change the thickness of this, it changes the tab distance here. It auto updates those things. So pretty cool. This looks pretty thin now, so I'm actually going to adjust that holder side so I can go in. And it's the neat thing about this is you can literally just go in and make your modifications, you know, in the part, finish the sketch, and then it updates. And since this is a copy of this one, whatever I did to this, it redoes that one as well. So, how do we make it? So let's get to it. First thing I want to do is I want to make a new component. We'll call this the holder base. The pin is roughly, I don't know, 5.5 inches long, roughly. So I'm going to make my base 1x6. And then I'm going to extrude that by 0.12, which is the thickness of the wood that I'm using. So that could change depending on what you're doing, but for us, that's the wood that we use. It's like 3mm, I think, that we use in our laser. And then I'm going to create a couple of construction lines. So I'm going to do a vertical one and a horizontal one here. Again, X toggles your construction line, so you can see it right here. Toggles that. And then I'm going to create a rectangle on one side, and I'm going to make, this is where the vertical pieces are going to, the sides are going to be connected. So this should be 0.12, which is the thickness of our material. And I'm just going to make this a 1/2 inch. And then I use the symmetry tool. I'm a huge fan of the symmetry constraint because it allows you to just do that. The other thing you could do is you could dimension this to here, and then you could pick this as your dimension divided by 2. That's another option. And then I'm going to go from here to here, and I'm going to say that that distance is 1.75. The reason why I don't do like 2.5 is because I don't want the pieces, when I do this, I don't want these to be on the very ends of the pin. Like I want the pin to rest on this. Let me see if I can. So right now the pin is attached to a different holder, but if you were to take this pin and lay it across here, I don't want it touching like the tip and the very end here. I want it kind of in the meaty portion of this. So if you were to measure, you know, the distance from, let's say, this circle here to, you know, this end of the pin. So that's roughly 3 point, it's tough to read, 3.867. So, you know, 3.8 inches. So if you think 3.5 is going to get you to about here, so that's kind of what I used for that. And then I'm just going to use the mirror tool. I'm just going to mirror these 4 lines across here. Get the exact same thing on that side. And then I can do an extrude cut through the part. make it fancy, throw in some fillets or some chamfers here on the edges. It's kind of your call, how you want this to look. Do something like that. Great. Let's go ahead and save this. I'm going to make a new component. Call holder side. Now here's the cool thing that I did that I think is beneficial is we're going to actually make this an adaptive interactive part with the base. So to do that is I right-clicked to make a new component, and then when I did my create sketch, I'm going to base it off of the geometry that it pulls when I pick this sketch plane right here. So I'm going to click on that right there. Use P for project, and I'm going to project some of these other things as well, so that I have all of those kind of dimensional guides to help me out. And then I'm going to just draw from this point up. So here's my slot. It's that width right there. And then I'm just going to kind of move my line over and then do some fancy, but really you don't even have to do the fancy. You can just do something like this to start with. I am going to create a line down the middle of this so that I think it picked the middle. And then I'm just going to dimension this to like 0.75. Dimension it, an inch tall. But then I want it to be symmetrical between here and here and here. So I'm gonna use that symmetry constraint and say these two lines are symmetrical about this midline. I then can put a circle at the midpoint, and again I'm going to toggle the construction. And then this is going to be based on the diameter of your pin. So mine's roughly a 1/2 inch diameter. So that's what I'm going to pick there. And I'm going to go ahead and finish the sketch and show you what the result is. So now I'm going to extrude all of like 0. Okay. Profiles. I want to select this, this, and this as well. And then I can say, instead of distance, go to object, and I can pick this other wall right here. Oh, select the right one. Let's try it again. Here we go. So I select that face, and now it automatically pulls it to that space. I'm going to say OK. And I want to show you some neat things that happen. So let's say that we change the wood that we're using. So instead of the 3mm, we're using like 5mm, 6mm piece of wood. And we want to laser cut that so it's a little bit more substantial. It's thicker. Or maybe we double up these and glue them together and put 2 in there. Well, we can go back to the holder base, go back to that sketch here, and instead of doing 0.12, let's say we do 0.24 because we did 2 thicknesses wide. And we go to finish sketch. Well, notice, look what happened to your holder side. It's now thicker. As a result, it's a double thickness. So it now is 0.24 as well. So that's kind of the cool thing, is that if you build a sketch off of another part, when you change that first part, it automatically adapts your new components that were based off references of that original. Same thing with the tab. Like if the tab you thought was too wide and you want to change that, so we can go back into this, and let's say we want this only to be 0.3, and then we go to finish sketch. You can see that the tab now on the holder, kind of messed that up. We can just go back and, it grabbed this extra part over here. So I think when I was selecting, or maybe when I did project geometry, I don't want to actually project that part of the geometry, which is fine. But pretty quick to change. It adapts quite nicely for you there. You can go back into this sketch and then you can put in the fancy stuff. So if you want to add some, some splines to kind of cut out here. And then again, you can use the mirror tool and mirror this across this line. And then you can finish the sketch, go back to your extrusion, and now we don't want to extrude these. Nice. And then we can add, some fillets to kind of round these all up. This is just kind of a matter of personal preference. Say OK. And there we go. I'm going to go back to the holder base and modify this back again. I'm going to leave this 0.3. I'm going to make this 0.12 though. So we're back to our original thickness. There we have it. All right, this isn't jointed in there, so we can make a copy of this. So right-click, copy, then paste. It wants us to revert because we moved it, so that's fine. And then now I'm going to use the joint tool here. So I'm going to joint, so this bottom face right here to the face inside of here. Now to get to that bottom point, if you hold down Control, it locks into that face. I can select that bottom point there. Say OK. Do the same thing here. Create a joint on this one. Come down in here. Say OK. And then you can put the name on this in here, or you could do it in Corel. Sometimes Corel you get different fonts and better fonts to use. So I would probably put the name on in Corel than in here personally. To make the laser file, we'll go ahead and do that since this is a laser holder. We're going to go into Drawing from Design. Sheet size doesn't really make a difference, but D is the closest to the size of our laser. And then we're going to keep it in landscape. The key to this is you want to get rid of all your extra lines on the sheet. So when you're doing this, see all these, oh, it wants me to drop the part. Oops, that's okay. We can move it. We'll delete it actually. We don't want that yet. We want to click on these lines and delete it, and click on your title block and delete it. So we have a blank space. I'm going to go back to base, make sure I'm 1:1. This doesn't help me. Like this is not laserable. I need to look at the profile. So I'm going to look at a top view so I can see the base from the top. And again, I want to do no hidden lines. I just want visible edges. I don't want it to be shaded in. I'm going to say OK. And then I want to remove the two holders. I don't want those. I just want the base. That's it. Perfect. Then I do another base view. And this time I want the holder. So I'm going to do a right side view so I can see it from the side, the profile. Drop it. OK. Turn off the base and turn off one of the sides. So I have a single side. Now, if you have the two of the same object, you don't need to do another one. You can literally just do these and you're good to go. At this point, you're going to export it to a PDF. If this is like one of your sheets from your drawing files, you can select, the current sheet and say OK. And then, save it to where you want to save it. But that's how you export your PDF. So again, click on OK. Save it to your downloads folder or save it to a flash drive that you plug in, something along those lines. Name it, make sure you put your last name on it so that way you know which file is yours when we import it into Corel. There's a whole video on how to import a file into Corel and how to use Corel, so that's in the laser operation video. But this just helps you, take your holder and get it laser ready. So that's one option. Let's look at another option for our pin holder. So this one is usually kind of a favorite of some students. So we're going to save it. We'll call it pin holder 2. we're going to create a sketch. It's going to be similar in dimension. We'll do a 1x6 again. We're going to extrude this 5.2. And then this time we're going to put the teacher's name right on here. This is going to be for 3D printing. So when I create a sketch here, I'm going to put some text, and I'm going to go from basically here to here, and I'm going to put it in the middle, pointed down. And the key here is to use all caps for this process. And then I like Arial Black. It's not the fanciest font, but it works well for this application. If you want to move it over more, you can. If you want to bump up the size to like 0.6, that's maybe a little much. But let's see, let's go 0.5. There we go. 0.5 looks pretty good. We're going to add some constraints to this text box. So we're going to make that horizontal. We're going to dimension from here to here, give us about 0.25. We're going to dimension from here to here, do 0.25 as well. And then we're going to move this a little closer. So I'm not going to dimension it. I'm just going to drag this and get it closer to the edge, about there. So I'm just making a judgment call on that. The other thing I could do, actually I might do this, probably better. I'm going to put it at the bottom. And then that way I can dictate where this is at. So I'm going to now dimension that from there to there. And I'm going to say 0.2. That looks good. And then I'm going to create a line. This is going to be for my revolve tool. And I'm going to make this 0.05, so 50 thousandths away. I'm going to finish that sketch. Now here's kind of the fun part, is if you use the revolve tool and you pick the revolve axis, is this here, it wants to cut it. Well, if you change that to join and you do this instead of partial 360, do like 70 degrees on this, and now say okay. So now it looks like the name is popping out of the holder, which is pretty cool. Now, how do you actually hold the pin? Well, we're going to put a little section on the side here. We're going to add an extra inch of material on this side, and then we can create a sketch on this surface, and this is going to be where we hold our pin. So if you want to create a circle, you can create a circle. We're going to make that circle like 0.75. Then we're going to dimension it from here to here. It's going to be a ½ inch. And then we're going to go from here to here. It's also going to be a ½ inch. And now we can extrude this up about 1 inch. And now we're going to put the hole in the top. So we're going to create a sketch on the top, a circle here. And now this is where we need to know the diameter of that pin tip on the end. I think it's 0.323. I don't know, I'm guessing. But we'll look here in just a second. So I'm going to finish that sketch. Let's go look. So I can go back to where I have my pin. I'm just going to inspect. And that right there, 0.348. Perfect. So I'm going to go back to my pin holder. Change that sketch to 0.348. And then when I do my extrusion here, when I cut into the part, I don't want it to be like just a straight cylinder, because if I do, it's going to be wobbly in there. I want to kind of hug the pin, which tapers. So if you click on this, you can get a taper to widen or to narrow, depending on what you want to do, and you can pick an angle. And this is where we made the angle back in our pin tip. This is why we did that. So if we go back into our pin tip and look, we can see that that angle was 7.8 degrees roughly. So now, when I'm doing my extrusion here, my taper angle is going to be -7.8, And then the distance has got to be greater than 0.82. So negative 0.85 is my distance. And again, I got that from this dimension right here. So from here to the end of the pin was 0.817. So that's why I went a little bit longer than that. And this creates then a tapered hole. And again, I can click on this. Oops. I'm going to do a section analysis. You can click on this face, and then you can actually see the taper in that hole. Pretty cool to see that. It's right there. And then, again, I can add some fillets. Add some on these corners here. Now with this one, you can actually add some fillets on the top too if you wanted. So you could do like all of these lines to fancy it up. I can also select a fillet here, and then might put a little bit of a chamfer on this to make it easier to kind of insert that into space. But that's a good looking pin holder that acts as a nameplate for yourself or a teacher or whoever you want to give this to. If you want it to be a little bit chunkier, go back to this original. You can maybe make that 0.5, make it stand up a little bit. There you have it. There's 2 pin holders for you. And then you can literally just attach the pin to the pin holder if you'd like. I don't know what just happened there. Let's go back to this. So here's what it looks like when it's in the second pin holder. I used a different shape on this one. I used chamfers instead of fillets. I wanted more geometric kind of shape on that, so I did a hexagon. But you can make those modifications and changes. You've got enough skill at this point to make a lot of cool things. But hopefully those help. Again, we'll see you next time. Remember, stop watching, start making. Go build something great today.